Hello, Clara-Jayne.
Hello.
How are you?
Good.
Clara-Jayne, thank you for helping me today. Clara-Jayne is currently holding a very short experimental apparatus. It's probably just about a meter long, and it's connected here to a tap, and it is a clear reinforced hose with a pressure gauge, calibrated pressure gauge tapped off it, and there is a lever valve at the end of the reinforced hose. Clara-Jayne, why do you think the hose is clear?
Because you can see the water.
You can see the water in it, yeah.
And you can see what is in it.
You can see what's in it. That's exactly right. I'm going to hold the gauge now, and I'm going to ask you, could you please check? Remember, we were looking at the gauge and we saw that there's two types of measurement for pressure on it. One's PSI, pounds per square inch, and the other is bar. Bar is given in red. So currently at the red, what is the needle at? It's actually for both.
It's at 0.
It's at 0. That's exactly right. Thank you for confirming that. And the reason that it's at 0, currently, if we open the lever valve, there's actually no water inside. Oh, well, there was a wee drop there at the end, show you that. But technically, there is no water actually pressurized inside the system. So, what we could do now, we could turn on the tap to see how much water pressure there is. So, how much pressure there is in the water. So, what I'm going to do now, you're holding that, and I'm going to slowly turn on the tap, but because it only takes a few turns, the pressure will rise fairly quickly. So now that I have the tap fully on, and this backyard tap is teed off the main supply to our house. So if you can come around here now and in bar, if you can tell me how many bar to the nearest number we are at, so the red numbers, what's the needle fluctuating past?
6.
Yeah, 6, because this is actually a pumped water supply. But if you hold on there now to the gauge, I think what will happen now if we turn on the water supply in the house, that this will actually, the gauge will move. What do you think?
Yeah.
And do you think it'll move up or down?
Up.
What do you?
Down.
I think it'll move down. I think the pressure will probably drop if we turn on the tap at the kitchen. Linda, would you turn on the kitchen tap for 10 seconds, please? Okay.
It went down.
It's down to
43. 4.
if you're measuring it, then 10 seconds, that's fine. Back up. It went down to approximately 2.5 bar. Linda, would you turn the kitchen tap on again for 10 seconds, please? Okay, yeah, down 3.4 bar. And now, yeah, back up. But what do you think happens now if we turn this tap on? Because that's a tap at the end of the day. It's a lever valve, but it's essentially a tap, because all valves and taps do the same thing. So we're going to turn that on now. Yeah, oh, so that's the same as turning on the kitchen tap. Oh, it's down, but we haven't it open full. We're going to open it up again. Down now. Yeah. Open it up almost full. We're down now, and the needle is actually vibrating, because I can feel the lever here vibrating, and that's something called water hammer, because it's not actually supported. There's no thrust blocks. We don't have this attached. We're holding it. It's not restrained, so it's just under 2 bar, 1.8 bar. And now, if I open it completely and we wash the car, making use of the water, we're now at a system where we have approximately 0.2 bar pressure. Now, is there anything else close to us that has pressure in it?
The engine of the car.
The engine of the car.
The tires.
The engine of the car has pressure and the tires of the car has pressure. So the engine, there'll be hydraulic pressure in there because of the lubricants used, and the tire pressure. So somebody's put on the kitchen sink there now, yeah. And the tire pressure in the car will be air pressure. So we can see how pressure fluctuates within a system, and we can see how useful it actually can be to know what pressure is in a system. So Clara-Jayne, thank you very much for your help. Thank you.